Hello everyone. Yes, till now we have seen about the random numbers, how to generate the random numbers, how to check for the how to test the random numbers, whether it is uniformly distributed or it is independent and all those things. Now we'll move on to the second chapter, that is random variables or the random variate generation. Here, before going for this one, you must see what do you mean by what is the difference between the random number and the random variable. Actually, what do you mean by the random number? Random number is a number which is taken from taken randomly from one pool. For example, you'll be having a set of numbers, that is the set of numbers. Among those set of numbers, you can just randomly choose some number, that is called as your random number. And always in some cases it will be having from 0 to, in our simulation we are having these numbers from 0 to 1, the range of the random numbers. And what do you mean by random variables? Random variable is a function, or it is like a function, okay, that maps the set of all the possible outcomes. And here we will get the outcome as a real number. Here the output of this random variate or the random variable is a real number, and this will be considered as a function. Okay, in this we have two techniques. One is inverse technique and one more is acceptance rejection technique. Now inverse transform technique will take later. Now I will just going to explain this acceptance rejection technique. This is just an example what I am taking here. Consider generating a uniformly distributed random variates between 1/4 and 1. Okay, now what are the steps you have to follow for this one? Step 1, first generate a random number R. If random number is greater than or equal to 1/4, then accept. X is equals to R and go to step 3. If R is less than or equal to 1/4, then you have to reject and you have to go back to the step 1. Okay, then if another step 3 is if another random variate is needed, go to step 1. If not, stop. If you want some more random variables, then you can go for the step 1 and you can continue these things from the random numbers generated. If you don't want any of the random numbers, for example, two random variables are enough, then you can stop this step. In the name itself, it is there, acceptance rejection technique. In this method, a random number is generated, and if that random number satisfies some particular condition only, then the random variable is generated. If the random number fails to satisfy that condition, then random variable will not be generated. This is called as your acceptance rejection technique. Okay, in this acceptance rejection technique, we have two types, that is your Poisson distribution and gamma distribution. First we'll see your Poisson distribution. This Poisson distribution, here this is one way of generating the random variants or the random variables from the given random numbers. These are the procedures you have to follow, and one more thing you have to remember, procedures are very, very, very important in terms of your exam. Okay, first set n is equals to 0 and p is equals to 1. N is thus number of your random numbers, the total number of random numbers. P is a Poisson distribution function. Then step 2, generate a random number Rn plus 1 and replace p by p into Rn plus 1. The random number, this is the random number which is given in the question that you have to take, and you have to multiply the value of p by that random number, and that is the new value of p. Then you have to check this e power minus alpha. What is this? Here alpha we have already discussed in the previous problems. If p less than e power minus alpha, then accept. Then capital N is equals to n. Otherwise, you have to reject the current n and increment the value of n by 1. And then again you have to go back to step 2. Then you have to take the second random number. First, you have to take the first random number. Until it accepts, you have to, means until this random number is rejected, then you have to take the same random number for this procedure. Once the random number is rejected, then only you have to increment the value of n, and then you have to go back to the second step and you have to take the second random number. Okay, you will just get it in the problem. See, I'm just going for the problem. Generate 3 Poisson variates. You have to generate 3 variables with mean alpha is equals to 0.2. Here we call this alpha as a mean. Alpha is equals to 0.2. Random numbers they are given. 5 random numbers are given. Means by using these 5 random numbers you have to generate 3 Poisson variates or the variables. Okay, first what you have to do? First you have to compute e power minus alpha. From your calc you can calculate it. E power minus 0.2, the value you will get it as 0.8187. Now what is the step 1? Set n is equals to 0 and p is equals to 1. Set n is equals to 0 and p is equals to 1. Next, step 2, generate a random number and replace p by this one. What is the first random number we have? 0.4357. So step 2, R1 is equals to 0.4357. Now I am just setting the value of P. P is equals to 1 into R1, that is P into Rn plus 1. P value is 1 I am taking. So 0.4357. Next, what you have to do? You have to check whether it accepted or not. P is equals to 0.4357. E power minus alpha value is 0.8187. Obviously we know 0.4357 is less than 0.8187. Then what you have to do? If it is less than, then you have to accept. That's it. Okay, accept and set n is equals to n. What is n value? N is equals to 0. Now capital N value will become 0. Okay, again you have to continue with the step because you have to generate 3 Poisson variates. Still we have generated only 1. So again just go with the step 1. Set n is equals to 0 and p is equals to 1. Then I'll take the second random number, that is 0.4146. See, this is second random number. Okay, once it is accepted, you have to just leave. Then you have to go for the second random number. I'm just taking second random number. R1 is equals to, means until it is rejected, you have to take it as R1 only. R1 is equals to 0.4146. P is equals to 1 into R1 is equals to 0.4146 again. If you check 0.416 is less than 0.8187, again you accept and set n is equals to 0 because here small n is equals to 0. Only it is rejected, then only the value of n will be incremented. And then third random number 0.8353, then again calculate the value of Poisson variate P, that is 0.8353. P is greater than or equal to, here 0.8353 is equal to 0.8353. So you have to reject and increase n by 1. Now n value will become 1 and go back to step 2. Okay. Now again in step 2 what you have to do? You have to select for the one more random number. Until it is rejected, all the random numbers will be considered as R1 only. Once the random number is rejected, then only we will consider that as R2. See, now till now here we have taken 3 random numbers, but I am not changing the value of R. It is still R1 only because we haven't go back to the step 2. Now only we are going back to step 2. Now I'll consider the fourth random number as R2. Then P is equals to P into R2. What is the value of P here? This is the value of P. Now P is not equal to 1. The P value has changed to 0.8353. Okay. Or else you can do it as R1 into R2. Yes. So this P into R2 you will get it as P is equals to 0.8313. Okay. Now step 3 again. This 0.8313 is greater than e power minus alpha. Again reject it at n is equals to 1 and return to step 2 but increment the value of n by 1. Now n is equals to 2. Now again step 2. The next random number, fifth random number, I am taking it as R3, that is 0.8004. Again, you have to do P into R3. What is the new P value? It is 8313. This is R1 into R2, is it not? So, P into R3 will get it as 0.6654. Then check P less than e power minus alpha. Because 0.6654, our e power minus alpha value is 0.8353. So, it is accepted and n is equals to n. That is capital N is equals to small n. What is the value of n here? 2. So, I am just taking 2. Okay. Now, if we want to continue, there should be a random number, but we are lack of random numbers. Now all the random numbers got over. 5 random numbers were given and this is the 5th random number we have taken. So I'll just stop this here. Next we'll move on to the table. See, this is the acceptance or rejection table. This is small n, what you have taken. These are the random numbers. This is the Poisson variate and this is the accept or reject and this is the result. First, n is equals to 0. First random number I have taken. This is the P I have generated. Here it is accepted. What you have got in your steps, the same thing you have to write it over here. Once it is accepted, then only you have to update the value of capital N. Otherwise, you should not update the value of capital N. See, n is equals to 0. Then again here 0.4146. Then P accept n is equals to 0. Again 0.8353, 0.8353, P greater than or equal to alpha, reject. I am not updating the n value. Again here it is rejected, I am not updating. Then n is equals to 2, 8004. Here it is accepted, I am accepting n is equals to 2. See, these are the 3 random variates we have generated, or the Poisson variates we have generated from your random numbers. So with 5 random numbers R, we generate 3 Poisson variates, that is n is equals to 0, 0 and 2. Therefore 0, 0, 2 are 3 random variates. Okay, this is how you have to just find out the Poisson variates. And I have just told you we have 2 different methods. One is Poisson distribution and one is gamma distribution. Now next we'll move on to the gamma distribution.